Hello and welcome to my YouTube channel. This is Jonathan Goldfish. Be sure to like, share and subscribe to my YouTube channel. Thank you for your support. Hello guys, welcome back to this channel. This is Jonathan Goldfish. So for this video today, we are entering the chapter 2 functions. Okay? So in the previous chapter, we are discussing about the quadratics, but this time for this chapter, we are discussing functions. Alright, what is the functions in terms of mathematics? It is basically a relation. So how to describe the term of the relation in the functions in terms of maths? From an equation function, right? Okay, how does the relation to be explained? Okay, so you can see this mapping diagram below. We can use object and image to represent the mapping diagram. Okay, so for each object we can call it as domain. For the image we can call it as the codomain, and there's a range where the codomain lies in the range. Alright, so in your secondary school such as SPM, IGCSE, you have learned these 4 types of relationship before you proceed to the function, which is the one-to-one relationship, many-to-one relationship, one-to-many relationship, and many-to-many relationship. Relation, okay? So, to verify that there is a function, you need to carry out vertical line tests, because each function, each codomain to the respective domain must have only one solution, only one, okay? Only one unique solution from one domain or many domains. So technically, for functions, only one-to-one and many-to-one relationship are valid, such as quadratic function, linear function. Okay, later on we are going to discuss some basic graphs that you need to master. Okay. Okay. I'm going to briefly explain these 4 relationships for each right now. So for one-to-one relationship means that, let me erase this for you. So here, let's say, for instance, here is your object 1, okay? Only maps to one unique codomain which lies in the range of its function, okay? Let's say the function f. You function the domain to produce the codomain that lies in the range. And what is many to one? That means two solutions that are functional for each to produce the same and unique codomain only. Okay? For one to many, that means for only a domain can produce 2 codomains that lie in the range. Let's say 3. 3 can function it. The domain 3 can function it to produce 5 and 7. This is one to many. But what is many to many? Many to many seems to be like complicated. That means from 1, let's say from 1 can produce 5 and 6. For example, 2 can produce 5 to 6 and 7 like that, and 3 can produce 5, 6, 7, 8 like that. So this is known as many to many. But for in our A-level syllabus, functions does not recognize many to many function, because many to many functions are not valid for defining a function. Okay? So I'm going to undo back the original one. Alright. So if you have no questions about the relationship, alright, let's move on to the next subtopic, basic graphs or basic functions. So these basic 7 functions you will need to master and understand, okay? So let's take a look at the first type of the graph or function, which is a linear function. So what's the general form of the linear function? Is ax plus by plus c equals to 0. Alright, that means you need to have x, you need to have y, and also a constant. This constant refers to the y-intercept, okay? And also there is an intercept form with the x over a plus y over b equals to 1. This is your intercept form. I believe these two forms you also learn you have learned from your secondary school, alright, SPM, IGCSE, or O level. You should familiarize about this. But in A level, intercept form is not usual. Usually, we leave the equations of a linear lines as either general form or gradient, or this so-called gradient form. Okay, the gradient form, I believe all of you math students already know the gradient form y equals to mx plus c, where m is your gradient and c is your y-intercept. Okay, and what's the formula? What is how to find your gradient? How to find your y-intercept? I believe these two things you also familiarize from your secondary school. Okay, this one we will discuss further in the chapter 3, which is the coordinate geometry. Okay. So in the next video, we are going to discuss the chapter 3. Alright. So let's take a look at the second functions, which is the quadratic function. I believe this is these quadratic functions you have learned from your chapter 1 or your secondary school. Okay? Use your chapter 1 knowledge to apply inside the function. That means you will realize that quadratic is a function. Because when you are using the vertical line test, you test like this, like this, like this, like this. No matter where does this yellow line move, it only intersects one point with the quadratic graphs. Okay? A vertical line test, right? So as you know, the general form is ax squared plus bx plus c equals to y. Okay? This is general form, but in vertex form is a times x minus h bracket square plus k equals to y. And this is your vertex form. Alright? So what informations you can obtain from the general form is your y-intercept, axis of symmetry, not axis of symmetry, the sum of root, and also the sign change, the sign of the coefficient of the x squared. Okay? And vertex form you can obtain the turning points, as I have mentioned and covered with you in the previous video. Alright? Okay, please refer to the previous video. I'm not going to discuss too much about here, and also you will know that how to find the discriminant. You need to use the b squared minus 4x ac, whether see if whether this quadratic have a roots or not. Okay, have a real roots or not. All right. For the third function, which is the cubic function, this one you will only learn the general form, which is the third power, but it is impossible for you to solve the cubic function by using that ridiculous formula you have seen from either in the social media, like for instance YouTube, Instagram. No. Okay, in A level, the examiner doesn't ask student candidates to solve the cubic function. Okay, so basically cubic function has a third power polynomial function with 3x intercept, aka 3 roots when y equals to 0. Okay, that's all for that. That's all. Um, that's all you need to learn about this. Okay. And the fourth function, which is the absolute value function graph. Okay, why does it so called absolute value? Because it has the modulus, um, these two vertical line, known as modulus. Okay, so to define the modulus for x, x is subset x subsets to the this R. What does this R denote? X belongs to all real numbers. Okay, how to know it is a real number? Refer to the notation list, okay, provided by the Cambridge. Okay, although you say x subsets to the real number, but no matter how your x is negative or positive, eventually your function, I mean the codomain or the range from reference to its domain x must be positive. That means for absolute value function, there is no negative range. Alright? Please aware that. So how to draw an absolute value function graph? First determine the inside function. Draw the original graph first. Okay? This one you should know from your IGCSE and SPM. That knowledge is your best prerequisite topics. Alright? Before to apply in this chapter. Okay, let's say you have a y, you have ms plus c inside the function of a modulus. You draw a linear line first, and then just invert this the negative range of the graphs just reflect upwards. Okay, with the send on the line about the line of the x-axis. Okay, just like that done. Okay, let's say you have the 2x minus 3. Okay, you will see that 2x minus 3. Let's say here is your minus 3, right? Minus 3 is an intercept. So you need to invert it upwards to 3, because when you substitute x equals to 0 and also your modulus, eventually you also get 3. Okay, just get rid away with the negative sign. Alright? So that's all for this absolute value function. Let's move on to the next function, which is a rectangular hyperbola, also known as reciprocal function. Okay? Or rational function. Why is rational function? Because it is a reciprocal of the function. Okay? Okay, this rectangular hyperbola has the general form of xy equals to c squared. Or we can also call this as the constant k if you want. Okay, and if you move your x downwards, you will form another general form of y equals to c squared over x. Okay, where x can't be 0, because when if you put x equal to 0 in the denominator, you will get an infinite undefined series or infinite series, which is infinity. Okay, so now I'm going to explain about the infinity. Okay, a line, okay, a dashed line, when the graph does not touch it, does not include the domain or the range, known as asymptotes. Okay, asymptotes. Apologize to my pronunciation. Okay, as long you can understand my pronunciation. I won't gonna explain further about the asymptotes. This one I will cover in the further maths topic, which is your chapter 2, rational function graph, from your further pure mathematics 1. Okay, stay tuned to my subsequent videos. Okay, let's move on to the positive square root graph. Okay, for this, as you know, what is positive square root graph? The square root refers to this one, right? This is known as the positive radical graphs, with the general form of y equals to square root of x. So how to draw a y equals to positive square root x? Imagine when you draw a x square graph, is a square graph, you will draw like this, correct? But this time for y, okay, for y and x, just rotate it in this way, okay? So now you treat your x as your y, you treat your y as your x, okay? Just move the square root to the other side or square at both sides, you will get this another general form, which is a y square equals to x. Treat your x as your y and your y as the x, and then draw it. So by right, your square root is increase. There's a increase gradient, then slowly increase the gradient for each domain. Okay, this is how you draw the positive square root graph. Okay, as long for y equals to square root x, your x can be only positive, include 0. Okay, x does not define when x is negative, because if you put x as a negative inside the square root function, you will get an imaginary numbers, and the function is the codomain is no longer a real numbers. Okay, it forms the complex number. Okay, all right. So let's say, okay, when you meet a question, it gives you the only this square root. This, you need to treat it as positive, positive radical square root of the function. Okay. When, okay, let's say I erase this away first. Let's say I put 4 inside. As you know, 4 is a perfect square, right? What is the square root of 4? If only this positive radical, it gets 2. Alright? Okay? And 2 square is 4. But negative 2 square is also 4. Okay? When you consider another negative, all negative square, you are no longer to call it as positive square root. You need to consider the negative range in the positive domain of the square root function graph. Okay? So that's why when you solve a quadratic equation, in the quadratic formula, it considers positive and negative sign. Alright? Because the quadratic formula assumes that when you solve a quadratic equation, you have two cases from the quadratic equation of that relationship. Alright? So when the question asks you to draw a positive square root graph, you just only draw this positive domain and positive range. Of course, it is only a positive range for this y. Alright? Okay, that's the end of the discussion about the positive square root graph. So let's move on to the last functions, which is the trigonometry graphs. Okay, so in your secondary school, you have already learned the trigonometric ratio, which is the sine, cosine, and tangent. All right. So how to draw a sine graph? It is a sinusoidal wave. Cosine is also sinusoidal wave, just that the difference between the sine and cosine by 90 degree. Okay, 90 degree minus this to convert to each other. This one I will explain further in my subsequent videos, which is the justified trigonometry. Alright, but for tangent graph is different. The tangent function is undefined when your domain is 90 degree and the 3 pi 90 degree or pi over 2, and also the 3 pi over 2 or 270 degree. Okay, so all of the, so that means the asymptote of the tangent x is pi over 2 plus or minus n pi, where n is your 1, 2, 3. No matter you add how many 180 degrees from the 90 degree, and it has many asymptotes because tangent has a cycle from this lower to higher like that. I won't gonna to explain further. Okay, please look through by yourself. So that's the end of the discussion of the basic graphs. Let's move on to the next subtopic of this chapter 2 functions, which is the transformation of the graph. Alright, in this subtopic, this subtopic is essentially important for this entire chapters, or in the entire pure mathematics paper 1. Alright, for the A levels. So you need to take note about this. Okay, in this pure math syllabus, you are going to learn about 3 transformations. They are translation, reflection, and stretching of the graphs. Okay, so what is the keyword, what is the technique that you need to answer for the question who asks you to describe the transformation of the graphs? Okay, these keywords you need to memorize by yourself. All right, first thing is the translation for the y. Okay, given, let's say given you have the y equals to fx, correct? Then you want to transform by a, correct? So let's say I say plus a. Okay, means that it is a translation for the variable vertically with the vector of 0 a. Okay, only change the y positions. That means, let's say here is your parabola quadratic graph. Originally it intersects with the 0. When you add a units for the y, it moves up a times. I mean the add a to the y position. Okay, that means the y-intercept initially is from 0. Not necessarily 0. Sometimes maybe generally is the original position to the new position. Okay, that means for here is your graph, correct? Here is your graph, correct? So I label it as original. When you have the translation with increasing or decreasing a units, for increasing you need to add a. So here is your original plus a with moving shift up a times. Not the multiply, is additional like this. Okay, original like this. So just change your position like this. If your a is a negative, by right you should shift downwards a like that. So here is your original minus a. Okay, so let's say here is your original graph. You shift downward the graph like this. So generally for the translation for the y, it moves with the position. When it is plus a at outside, it moves upwards. When the a is negative, the graph moves downwards. Alright, but for the y is opposite. Okay, because you only change the domain inside, change the x inside. Alright, for the horizontal position or the x. Okay, you just only transform your x only. Alright, so let's say I'm giving you the quadratic graph again. So let's say here is your original x. Okay, if I put negative, it shifts rightwards. Okay, so here is your negative. That means you add original plus b. When you have x become x minus b. go back to the original position. When your b, when you let your x become x plus b, you will shift your original minus b to the left hand side. So generally for the translation, for y, when the outside, when it transform outside like this, means move upwards. Negative, move downwards. But for the x is different because negative, move to the right side, positive, move to the left side. Just remember like that. Alright? So generally, the transformation of the graph by the vector AB, where y equals to f x minus a, where a is a positive, move to the right side with this general form, and b, when the b here and b here are both positives. Okay? So please memorize this. This is essentially important. Alright? If you not understand enough, later I will use Desmos to demonstrate to you. Okay? To let you further understand. Okay? So next transformation is your reflection. Okay? What is reflection? Given there is a y equals to fx, if you put negative at the entire function, entire fx outside, there is a reflection of the graph y equals to fx in the x-axis. Okay? So let's say I can give you a linear line, okay, a linear graph, and I want to make a reflection, all right, about the x-axis. This is your the axis of the reflection. Okay, that means your negative becomes positive, your positive codomain, I mean positive range, become negative. All right. Because you only change the sign of the y. I mean the sign of the range. Okay. But for the oh yeah, this is the similarity. For the y equals to f bracket of negative x, y equals to f bracket negative x entire like this, that is a reflection of the graph in the y-axis like this. Okay. So how does it work? For the notes I have given, I think you shouldn't be understand. Okay. So let's say here is your linear line, correct? I want to make a reflection, correct? You just that you only change you just only reflect this one and also this one. Okay, because you want to reflect about this axis, correct? If you're not enough to understand about the reflection, later on I will use Desmos for you to understand further. Okay. So generally, for the reflection of the y, for y equals to negative fx, there is a reflection of the graph y equals to fx, reflection of the graph of the y equals to fx in the x-axis. For the domain changes its sign, there is a reflection of the graph y equals to fx in the y-axis. Okay, about this center line of the axis. All right. Okay, so let's cover the final part of the transformation, which is the stretching of the graph. Okay, that means when given there is a y equals to fx, you transform the fx into k times of the fx as your new transformation. I mean the new function by multiply by let's say a constant k. Okay, any multiply times there is a in the or at the outside of the fx, there is a stretch of the graph y equals to fx with a factor of k. Okay, that means for the y position, you stretch k times. That means the in in the fixed domain, their range or their codomain must be times k times. Okay, from the original codomain from their respective domains. Okay, so there's a stretch of the graph with y equals to fx with the factor of the k that is parallel to the y-axis. Okay, please remember about this. Very important. Okay, if you are not memorizing about these keywords and sentences, you are not able to answer the a type of the question about the transformation, regarding the transformation. Okay. I'm sorry, please correct this. There is a correction. This is not a, this is your k. Okay. That means when fx times k, let's say your tree must be times k in the same domain. What is its domain? Is 0, correct? Is 0. Okay. So let's take a look at the parallel to the x-axis. Yeah, it is also different from the y-axis. Same as the translation. Okay. So when you times your domain by h times, let's say a constant h times, you have the stretch of the graph y equals to fx with the factor of 1 over h. Okay, which is the divide by h that is parallel to the x-axis. That means your domain will shrink for their respective and fixed codomain. Okay, let's say originally you have x1, you shrink. Okay, you reduce your domain by you multiply your domain by 1 over h time. Okay, the reciprocal of the constant. That means you divide by h times. Okay, you shrinks for it is parallel to for its transform for its stretch is parallel to the x-axis. Okay, so generally for the f bracket h times the x, there is a stretch of the graph y equals to fx with the factor of 1 over h, which is parallel to the x-axis. Alright. Okay, let's take a look at the summary. For the vertical transformation, for fx plus a as your new function, there is a translation of 0a. But okay, for the reflection, you multiply, you change the sign to negative beside the entire fx. There is a reflection in the x-axis. Okay. Of course, you need to say reflection of fx in the x-axis. Okay. This is for guaranteeing you to obtain the marks. Okay, for the fx times k as the new function, you have the vertical stretch with the factor k, or you can say that stretch parallel to the y-axis with a factor of k. Alright. For the horizontal transformation, if your domain of x change with negative a, there is a translation of a0. Okay, this a is positive when you are given f bracket x times a, x minus a. For the reflection, you have put a negative, there is a reflection in the y-axis. Okay, and for the f bracket, a constant a times x, there is a horizontal stretch with a factor of 1 over A. Okay, that means the horizontal stretch has two transformations which are opposite to the vertical, which is opposite to the vertical one. All right, there's a horizontal stretch with a factor 1 over A. It is the reciprocal of this constant, or stretch parallel to the x-axis with a factor of 1 over A. Okay, so actually I've done with you the discussion about these three transformations. Now let's proceed to the final part of this subtopic, which is the order of transformation. Okay, there is no general theory for you to learn. Instead, I can indicate to you some examples. Okay, so let's say I have stretch parallel to the y-axis with the factor 2 and translation of 0, 5. Okay, what is your new functions, like from an ordinary y equals to fx? Please change it here, y equals to fx. Here is a correction, sorry about that. Okay, the new translation. So this is your first step, this is your second step. All right, so you times your parallel to y-axis, that means you need to times the entire fx by 2 times. Entire finish the first transformation, then you translation 0, 5. That means you need to add 5 beside the entire to fx. Okay, so here is your result of the new function through the two transformations. Okay, what if I swap the order of the transformations? I let the translation 0, 5 as the first transformation, and then the next step is the stretch parallel to y-axis with factor 2. What will happen to the new function from its original function, let's say y equals to fx? First translation 0, 5, that means your ordinary fx must add 5 first, and then you have and then you stretch the first transform function by times 2 to this entire function. Okay, entire function of the result from the first transformation. Okay, so you need to times 2 the entire function, the function after transformed by this first step translation. Okay, you need to times 2 here and here. So what's the difference you can see? You can compare. Although there's a 2fx at both sides with the swap order, however, you can see that there's a different constant. So what does this indicate to you? I've summary to you here. That means generally order is important for multiple transformations. What does this multiple transformation mean? It means for the multiple transformation, like usually two transformation or three transformation like that, you must consider its order. Okay, very important. Okay, this is necessary important. Please take note about this transformation. All right, so before proceed to the next subtopic, which is the domain and range, I'm going to use the Desmos to visualize how does the translation, reflection, and this stretch work. Okay, how do these three transformations work through a graphical method? All right, okay, I'm going to show you illustrate how does the transformation work in a Cartesian graph. So let's say I'm using this Desmos, alright? So here is a linear line, okay? I set this to 1, set this to 1, in order to let this linear function become y equals to x, alright? So here is your y equals to x, okay? So let's start from translation. If I want to do a vertical transformation, the translation of in the vertical variation, vertical transformation, let's say I have to add 1 unit. That means you need to move upwards this linear graph, linear straight line, upwards by 1 unit. So I have to variate d, okay? So let's variate d by 1. So if you transform it through translation 0 1, your graph should be looks like this, okay? If you want to move downwards by 1 unit, so your graph should be look like this, okay, with the -1 intersections. Alright, so for this d, it is a translation of 0d, where you want to change the y-intercept in this linear function, okay? So let's take a look at the reflection. So for the reflection for the entire one, you just put negative, okay? Put negative beside the y. Okay, let's close the bracket. And your graph should be look like this because you reverse the gradient, okay? Reverse the entire function. So similarly, your gradient must be reversed, okay? So it is a reflection through the y in the x-axis, okay? So let's have the stretch. If I want to say stretch parallel to the y-axis, so I have to multiply this entire by a. So let's say I change my a into 3 times. Okay, that means for a same domain, its y coordinate is getting 3 times bigger. Okay, increased by 3 times, or generally 8 times. If you want to transform it to a new function through stretch parallel to the y-axis, okay, you need to change the y coordinate by 8 times. So for example, I change my a as 3. That means you need to stretch parallel to the y-axis with the factor of 3. That means you need to increase by 3 times in the same domain, and it gives the y 3 times of its original y coordinate, okay? So if I add c at beside the x, or let me demonstrate this for you lah. Okay, if I add 1, it moves to the left because you need to change the x coordinate, okay? So this is the translation of -1, -1, 0. You just only change its x position, okay? So for the translation, x and y are in opposite transformation, okay? So for y, when the translation moves up, it moves up. If the translation in the x is to the left, that means the graph moves to the right, okay? So for x is opposite. So if I variate my c into negative, it shifts to the right by 1 unit, just like that, okay? So yeah, it makes sense. Okay, let's vary the b to understand that the stretching parallel to the x-axis with the scale factor of the reciprocal one. Okay, if you see the b beside the x, if I times my x by b, let's say I move my b as 3, so you can see that its x coordinate decrease increased by the reciprocal I mean the divide 1 over a times. Okay, always for the stretching it is opposite from the y. Okay, when you give your coefficient of x as b, its factor must be 1 over b in order for its gradient to be more positive. Alright, okay, so this is how you understand the stretching that is parallel to the y-axis with scale factor of 1 over b. Okay, so that's the end of this interpretation for the tree transformation for a linear function. Okay, so let's reset back. Okay, let's proceed to the next function, which is a quadratic function. Okay, but for this part, I'm not going to discuss for the cubic function because cubic function does not exist in your syllabus, in this A-level syllabus. Alright, so here is an ordinary x squared quadratic function. Okay, if I want to change the position in y direction, I just change my d. Okay, so I let my d become 1. That means your quadratic graph moves up by 1 unit. Okay, let's set the d as negative. That means for the translation 0, -1, the quadratic moves down by 1 unit as well. Okay, okay, let's see for the x. If I let's say I use the bracket, I only change my x. If I move my x to the right hand side, I need to let my c become negative. Okay, same as the linear function that I demonstrate to you. Okay, and also if I let my c become positive, your quadratic graph moves to the left. Okay, that means the quadratic function, the graphs moves to the left side and let the x coordinate become more negative. Okay, so let's explain about the reflection. If I want to reflect in this entire function by y, I need to bracket it up. So I put negative here. Okay, so it will reflect on in the y-axis if I reflect the entire function like this. Okay, meanwhile, not meanwhile, or else if I want to reflect in the y-axis, I will put the negative. But for quadratic function, no matter the coefficient of x is, I mean the sign of x is positive or negative for the quadratic function, its graph does not change because the graph of the left quadrant and the right quadrant one are the same, are identical. Okay, I'm sorry about that. I forgot to discuss the reflection in the x-axis for the linear function. Okay, let's show about this. If I change my sign of the x as negative, I think this one you have not not understand enough. So I randomly set C as let's say -2, D is 6, and the B is a factor, okay, about 2 like that. Okay, you can see the original graph. Let's say I set this linear function as 2x 2x plus 6. If I only reflect, or I need to reset this into let's say I'll set it to 10. Okay, now over here I have 3x plus 10. Okay, if I want to reflect in the y-axis, I need to put negative inside the x. So what will happen to the graph? So your graph will undergo reflection in the y-axis. Okay, so for this part, move to the opposite quadrant, and this part will move to the opposite quadrant as well. Okay, so this is how does the reflection in the y-axis work for negating the x. Okay, so this is actually the end of the discussion for the linear function. So now I'm going to discuss the stretching for the quadratic function. So let's change the a. Let's say I change it into 4 times. So as your a becomes more positive, I mean become the magnitude is increasing, the graph will shrink. Okay, that means for the same x coordinate, the original y coordinates will times a, increase by 8 times. Let's say this is a equals to 8. That means after transform, I will transform this into the each y coordinate as 8 times of its original value. So this is known as the stretch parallel to the y-axis by a scale factor of by the factor of 8. Okay. Okay, let's return back to 1. Now we stretch the quadratic graph that is parallel to the x-axis. What will happen? Okay, if I vary my b into more positive, so it is a stretch parallel to the x-axis with the scale factor of 1/6. Okay, so this is how do you interpret its transformation. When you see an original equation to the new transform equation, then you need to identify how does the transformation work. Okay, so for this, generally for these 3 transformations, translation and stretching are opposite to the x and y, except for the reflection on the y-axis. It reflects, it negates the x. For the reflection in the x-axis, it negates the entire function. Okay, so I have illustrated to you 2 examples. Alright, and I don't think I will cover the sine, cos, tangent. So for the behind these three part, I will illustrate to you in the chapter 5, which is the trigonometric function. Okay, so now we are discussing the the last part. I mean the another extra part of the function graphs, which is the absolute value function graph. Okay, so you must know that for the absolute value function, what is its ordinary function? Its range is always positive because you have modulus. You have modulus it. Okay, that means you need to let this negative range, okay, the negative range of it for the negative domain becomes more negative. Okay, so let's say I change my d, it also changed the positions fundamentally. Okay, when the d is positive, this d is positive, it moves up with how many? Okay, so let's say I set my d to 10, so the absolute function graph moves up by 10 units. Okay, and also similarly in the negative direction. All right, and how about the reflection? Okay, the reflection of the absolute function, so I just put negative. Is if let's say I put the negative outside, so it reflects on the x-axis. All right, that means for this function it is always negative for the range. If I only negate the x, so I put the coefficient of x as negative, it doesn't change. Why? Because this gradient and this gradient are the same and identical. Okay, that means generally for quadratic function and absolute value function, they do not have the reflection in the y-axis because the graph, the pattern of the graph on their left hand side and their right hand side are identical. Okay, all right, now let's proceed to the discussion of the stretching for the absolute value function graph. So if I change my a as let's say I put a as 4 lah. So you can see that for the same domain, its y coordinate increases by 4 times. That means generally for the same domain, that is a stretch that is parallel to the y-axis with the factor of a times. I mean with the factor of 4. Okay, so let's get back the 4 back to 1. So let's see the coefficient of the x that is b, because we want to investigate the stretching that is parallel to the x-axis with the scale factor of the reciprocal. Okay, because in order to let this gradient, the coefficient of x, become more positive. All right, let's say I set my b as 5. So you can see that for the same y coordinate, its x coordinate reduces by b times. Not reduce, it's divide by b times. Alright? So generally, for the x axis, I mean for the x direction, it undergoes the stretch parallel to the x-axis with the scale factor of, with the factor of 1 over b. Okay, so this is the advanced explanation of these three transformation functions. Okay, if you have any issues or any obstacle, don't hesitate to reach out to me. through my contact or WhatsApp. Alright? Let's proceed to the next subtopic, domain and range. So, what is domain? Domain is your X object. And what is range? Codomain lies in the range from the domain map. Okay? So there is so usually for the question it gives you this expression. For this expression, it represents F maps to the X to give Y. You can convert this expression into this form, which is the Y equals to Fx. Alright? And you need to read through the question carefully. Sometimes the question comes up with X subsets to the real numbers, or you may see different kinds of the situation, like let's say X greater than 7, X greater less than 5, and X is greater or equal to 7. Okay? So anyway, when you're solving a passive questions, which is the function, you need to take a look at the function and the domain or the range. And for this subtopic, you need to know how does the domain convert into the range. Okay? I mean the set of value of the domains into the range. So that means generally Fx is always only 1. Okay? Only one codomain that lies in the range from 1 or more X. Okay? So this is what am I trying to explain. Alright? Functions with the similar expression may have the different domain. So this is the piecewise function. You will learn this subtopic later. Alright? So sometimes for the different domains have the different range. Okay? So here is a special case, which is the reciprocal. Okay? That means you need to swap. You need to swap the numerator and denominator in the opposite sides. That means you need to let your entire fx to the denominator to let it become like this, y equals to 1 over fx. So let's say I give you an example of the sine function. So each half quadrant has a maximum point or minimum point. So your maximum point will become a minimum point, and the minimum point become a maximum point, and your zero intersections will become an asymptote. Asymptote will become 0. This one I should cover with you with the subtopic of this same chapter before. Okay? So for more details, I will cover this in further mathematics chapter 2, which is the rational functions and graph. Alright? I will not discuss this too much. So let's proceed to the next subtopic, which is the piecewise function. Okay? So why is it called piecewise function? Because this piecewise function, it acts differently on different piece of the function. So let's say an fx has two functions, a quadratic and the trigonometry. Of course, with the different domains, that means they give the different range. Okay? So there's nothing here for you to discuss. Okay, let's proceed to the next subtopic, which is the composite function. Alright, this subtopic is also important. Alright, and you must know how does this composite function form. So let's use the arrow diagram to represent. If I map my x, let the f maps the x into the fx, and then I map again. So the range of this as the object of the g. So I mapped it again into gfx. So order is important. All right. Let's say how to form fgx. Map g first, function g maps to the x first, then f to form fgx, and it is not equal to gfx. Okay, gfx defines f maps to x first, and then g maps to the fx. Okay, so what is the condition to form the composite functions? Of course, you need to obtain the domain of the fx and domain of the g function g by looking the range and domain. So what is the condition? Okay, composite function only exists when the range of the gx, that means the range of this, lies the domain in the fx. Okay, let's say your fx is trigonometric function, but I want to map um, with a quadratic function. So that means the range of the quadratic function must lie with the domain of the trigonometric function, something like that. Okay, for this gfx, that means the range of the second function need to lie in the domain of the first function, technically. Okay, so here is a summary of the composite function. I mean the condition, and also some notes you can read through this by yourself. I mean I've go through with you about this. And as always, the question given must in order to form the composite function, must let the f and g are different. Let the f and g be different. Okay. All right. Let's proceed to the last subtopic of this chapter 2 function, which is the inverse function. So, what is inverse function? Originally, in an ordinary function, your f maps the x to y. But this time, for inverse function, it maps the y back to x. This is so-called the inverse function. Okay, what is the condition? Okay, for the inverse function, the domain of the inverse function equals to the range of the function. Makes sense, right? And the domain of the function must equals to the range of the inverse function. Okay, so let's say here is your f. My domain of the inverse function is here. Is the range of the fx is also here. Then for the domain of the function is here. The domain of the function is here. The range of the inverse function is also here. So please take note this statement. Okay. So there is another condition for the inverse function. Okay, inverse function only exists when fx is 1-to-1 relation. Okay, or you can do the horizontal line test to test that an ordinary function has inverse or not. Okay, so why quadratic does not have inverse function? Because it is a many-to-one relation, right? By drawing a horizontal line that cuts multiple points of the graph of functions. So that's why this quadratic function does not have an inverse, because you are not able to carry out the inverse function in the quadratic function, even you use the vertex form, unless you can sacrifice some domain. This one we will do some exercises, see if there's a type of question like this or not. Okay, so how does the horizontal line test carry out? Just draw a horizontal line, but make sure this horizontal line only cuts one point to the graph of the functions. That illustrate that this graph is one-to-one relationship. All right. So if you convert this fx into your inverse function, so you can see that this graph of inverse function is the reflection of the fx about the line y equals to x. Okay, with the center of the diagonal line y equals to x. Okay. So that's the end of this chapter 2. Alright, before I end my video, we are going to take a look at these exercises. Alright, let's move on to the exercise for chapter 2 before I end this video. And these 60 questions that I've extracted from Pure Mathematics 1 course book and past year questions. Alright, let's take a look at the first question. And some of these questions that I've ticked, I will only discuss some of these questions, and the rest of the questions you need to try out by yourself. Alright, so let's take a look at the first question. Which of these graph represents functions? If the graph represents a function, state whether it is a one-to-one function or many-to-one function. Okay, so let's do A. Given the equation of the A is y equals to 2x minus 3 for x subsets to all real numbers. Okay, so ask yourself, this is a linear equation. Alright, if you sketch this in your graph, I mean a Cartesian graph, it is indeed a function. So yeah, it is a function. But what is the type of the function? Okay, so you can see that for different domains, it only has a unique range, a unique codomain. All right, so here is your domain, right, and your y. Okay, so each different domain has the different range. All right, this is obviously one-to-one, or you can carry out the vertical line test. That means no matter how do you shift this vertical line to the left or to the right, it only intersects one point with this linear graph. So therefore, it is a one-to-one. Okay, one-to-one function. I will erase this graph for the other questions. I mean the other parts of questions. So let's take a look at the B. B is a quadratic, y equals to x squared minus 3, and also for x subsets to all real numbers. And yeah, it is obviously a function. Okay, if you sketch the graph like this, so by right your quadratic graph should look like this. And what is the type of its function? Okay, when you draw any horizontal line, so you can see that for the same range, it has a different domain. Like you're solving a quadratic equation, you need to let this quadratic equation equals to 0. That means you need to solve for this x coordinate. So that means for the same range, it has a different domain, okay, or two distinct roots. So therefore, generally, this function is a many-to-one function. Okay, just like that, done. Okay, let's proceed to the G. Okay, G is a square root graph. Y equals to square root of X. For X are all real numbers. And also your X, provided your X must be at least 0. But I think the purpose of the question wants you to assume that your X is at least 0. Okay? And X are all real numbers means that X can be any numbers, just that your X need to be real. Okay? Real numbers can be also a negative number, so just cancel it. Alright? Because the square root function only the X to be positive to define this entire square root function. Okay? So obviously this is a function. Why it is a function? Because you must let your Y on the left hand side of the equation and equals to in terms of X. The function in terms of X. Alright? And it is a function, but what is the type of the graph? So let's draw a square root graph. So your square root graph should look like this. Okay? Means it is a y squared over x lah. Okay? So obviously it is a one-to-one because you only assume that it is a positive graph, right? It has only the positive range with the positive domain. Alright? So for the different domain, they have the different respective range. So that means this positive square root, okay, because of this positive radical square root. So that means this function is a one-to-one function. Okay. Okay, let's take a look at the h. So h, you see h is a y square equals to 4x, but for x are all real numbers, subsets to all real numbers. So is it a function this time? Many students thought that only move the square to the other side or square root at the both side to become a function. Is it correct for this? Because the question doesn't want you to solve, doesn't want you to express y in terms of x, right? So is it a function if it gives you original y square equals to 4x? This time, the answer is no. Okay, this is not a function. Why? Because you didn't leave your y square as y on the left hand side of the equation originally. So that's why this entire equation is not a function. Okay? So that's the end of the discussion for this first question. Okay. So let's take a look at the second question. Second question is about the transformation. So here you have an original fx graph. Okay? The question wants you to draw the graphs of the following. Okay? With fx minus 2. So it is a translation of 0 to. That means your fx graph moves down by 2 units. Okay? So you can see here 2. Original 2 is a y-intercept. You shift down 2 units by 2 units, so your 2 will change to 0. And similarly for this and this will go down 2 units without the changing the coefficient of this fx by how many times, just remain one time. So you shift 2 units like that. Okay, so first of all you need to plot the points of the new graph. Okay, and then you draw maybe I change the color. and then you draw the new graph. So this is how you draw a new graph by through this transformation. Alright? Okay, let's take a look at the second part. Maybe this time I will use the different color. Okay, so the second graph is f bracket f of the x minus 3. So what is the x minus 3 means? It is a translation of 3, 0. You need to move to the right side by 3 units because the general form is negative. That means you need to shift this original fx graph to the right side. Okay, so I will erase this away. Okay, so you have 1, 2, 3 right here, 1, 2, 3 right here, and also 1, 2, 3, and just draw it. Okay, this is how you draw the new graph for this transformation. Okay, let's take a look at the third part. Let me erase this away. Third part is the y equals to f of 3x. Okay, for now, the coefficient of x changes by 3. That means that you, this fx undergo a stretch parallel to x-axis with the scale factor of 1/3 because in order to increase the coefficient of the x or the gradient. Okay, so for the same y coordinate, you need to divide your x coordinate by 3. So here you have 1, you need to divide by 3, so it's 1/3. For this new transformation of x coordinate, I will approximate the 1/3 position about here. And for this is 2/3. 2/3 is about here. Okay, and you have to maybe about here. Okay, so you draw it like in this way. Okay, so there you go. Here is your transformation of the third part. And I'm sorry for this. This is not y equals to gx. It is a fx. So please change the question. All right. So this is how do you draw a new graphs through the transformation for the questions below. Okay, in this way. Alright, so I will not discuss this question anymore. You may try out by yourself. Let me erase this away. I'm sorry. Maybe I just use eraser, erase enough. Except for this y equals to fx, not gx. Okay? So let's jump to question 6. Okay, question 6. The curve y equals to x squared is translated 2 units in the positive x direction. Find the equation of the curve after it has been translated. Okay, highlight the words translated 2 units, positive x direction. Okay, what does it mean? You need to transform by -2. This one you should memorize it. It's the general form of -2. -2 means you change your x, you move your graphs to the right hand side by 2 units. So this is a translation. Alright. Oh, wait. Sorry, I need to change back to the original color that I want. Okay, this is the color one that I want. Okay, let's take a look at the second part. So the curve x cubed minus 4 is reflected in the x-axis. Reflected in the x-axis and find the equation of the curve after it has been reflected. Alright, so here you have the original graph, okay? The question wants you to find the equation of the new curve. The new equation of the curve after this transformation. Okay? Reflected in the x-axis, that means you need to negate the entire function. So here is your new transformation. Okay? So for me, I will leave it in negative x cubed plus 4. Or equivalent, you can leave it as 4 minus x cubed is also acceptable. Okay? So that's the end of this discussion of this question. Alright? I will clear away. Alright, let's move on to the question 8. Describe the sequence of a transformation that maps the curve y equals to x squared into this half of bracket square, a bracket cube of x plus 5. Okay, for 8a, so you have x plus 5. That means you have a translation of negative 5 because this you have the positive 5. Okay, that means the general form, it has a negative 5 transformation 0. And you see the half. That means you need to stretch with the half. Okay. So you have the stretch parallel to y-axis with a factor of half. Okay. Okay. Or you can write you can swap the order, but with the different description you can also write the stretch parallel to the x-axis with the scale factor of one. Oh, cannot. Only this answer is accepted. Okay. So you only have translation and stretch parallel to the y-axis with the factor of half. Okay. For this entire function. Okay. So let's proceed to the B. The curve. Describe the sequence of transformation that maps the curve y equals to x cubed onto the curve negative half bracket cube x plus 1 minus 2. So, okay, first step, you have plus 1 and negative 2. So that means for this b, you undergo a translation. So you have plus 1, so you have negative 1 generally, and also negative 2 is negative 2. So you have a translation negative 1, negative 2. Yeah, correct. Oh, you need to put 1 and 2 because you want to follow the order. Okay, translation negative 1, 0 first. Okay, you transform this first. Next, you have um reflection for this. Maybe I don't do reflection first because you have C the negative. All right. So after I've transformed this, I need to I need to say stretch parallel to y-axis with a factor of half. Third, you can say translation. Okay, because you have negative, so if you factorize it, you have positive. So translation of 0 to. And finally, fourth part, you can say you undergoes the reflection in the x-axis because you undergoes the reflection of this entire function. Okay, you negate all function and then you expand inside like this. Okay, but I think these steps, this sequence of transformation are too long. So what is the alternative answer that I can give? So for the other students, they think, okay, first you can have translation of negative 1 and 4. Okay, because you start initially you have x cube. If you have negative 1, you can x plus 1 cube and then plus 4. Okay, and also you can have the stretch parallel to y-axis with a factor of half. Okay, that means you times the entire function by half like this. So 4 over 2 is a 2. Yeah, makes sense. And finally, you can have the reflection. Reflection in the x-axis. That means you need to negate all of this and expand inside. Yeah. So this answer is also acceptable, just that you need to label the sequence of the transformation. As I mentioned just now, the order is important. All right. Okay. So let's take a look at the C. I may clear this up for me to do C easily and free some space to do C. Okay. For C, describe the sequence of transformation that maps the curve y equals to cube root of the x onto the curve of this. So what's the sequence to transform this. So initially you can write y equals to cube root of the x, and you can see that you have the x minus 3, so you have the translation. Okay, you have a translation of 3 0. That means you shift your graphs to the right hand side by 3 units first. Okay, or you can do in once, because you see there's a negative, so you can factorize it into this in this way. And you can see you can also factorize 2 outside, so you can have the negative 2. So you can directly describe this as the translation 3 negative 2. And next you have a stretch, okay, by times 2 and then the negative. So you have the stretch parallel to y-axis with a factor of 2. Okay, because this entire function need to stretch by 2 times. Alright. And finally, you negate by reflection in the x-axis. That means you need to reflect for the entire function, okay, in order to satisfy this new curve. Alright. And don't forget to label the sequence. Okay. Alright, after you have done the discussion of the questions from the course book, let's discuss the passive questions. But I'm directly enter the section of the challenging questions. Alright. So for this, the rest 8 questions, I will only discuss like this question 10, question 10 and question 15 enough, and the rest of the passive questions you need to try out by yourself. Okay, so let's take a look at the question 10. This is the 9709 May June 2010 paper 11 question 9. Okay, so let's take a look at the question. The function f is defined by this expression f, the ratio of f to the x maps to, the f maps to the x to the 2x squared minus 12x plus 7 for x subsets to all real numbers. For the first part, express fx in the form of a bracket square of x minus b minus c. You need to express this into the form. So you may recall this from your chapter 1. Okay, if you still forgot, you should recall back what is CTS. And please refresh back what you learned from your chapter 1. I'm not going to repeat this again. Okay, so I will directly give you the solutions. And if you still not able to answer the rest of the questions, or you have some confusions, no worries, I will provide you the full solutions for entire exercise for this chapter and as well as the chapter 1. Okay, so you can write it like this: fx equals to 2x squared minus 12x plus 7. What should I do now? I factorize these two factors in order to let the coefficient of the x squared become 1. So I factorize 2 outside. Here I have 6. Yeah, 6. And also here for the 7 is 7 over 2. Maybe I use the ordinary bracket, not the square bracket. Okay, Now it's time for applying the CTS method. So okay, add the -6/2 at the both side. I mean plus and minus, in order for you to completing the square at the first term. So -6/2 is 3, -3. Okay, so I have -3 squared. And -6/2 is -3. -3 squared is 9, -9. Okay, so use your calculator to calculate it. -9 plus 7/2 and times 2 back. So I have -11. So this is your expression. I mean your final answer for this first part. Okay. So if you are able to do this step, well done. Well done. You know how to use the CTS method and you fulfill the requirement from the questions. Okay, in the form of a bracket square x minus b and minus c. So we can deduce that the a is 2, b is 3, and c is 11. So from this vertex form, what can I deduce? Deduce that there is a turning point of 3 and minus 11. Okay? So this vertex form is useful to answer the rest of these questions. I mean the rest of parts of this question. Okay? So let's take a look at the second part. State the range of f. What is the range of f? You see, your a is positive, correct? That means this quadratic function has a minimum point. So what's the range? Okay, so you can write fx is greater or equal to -11. That's all. Why? Because you see, given that here is your quadratic equation, correct? So here, let's say here is your turning point, correct? Okay, and here is your range, okay, until infinite. But start from this at least -11. So this is how you answer this second part. Okay, in order to give the correct range based on their function and identity. Okay. Third part, find the set of value of x for which fx is lesser than 21. You can have two methods. Let me provide you the simplest method. Okay, substitute fx with the vertex form. Okay. And then 21 plus 11 divided by 2. So that means your x minus 3 squared is lesser than 16. So in the range, you have the, okay, if you let this inequality in the equal sign, so you have x minus 3 equals to 4, x minus 3 equals to -4. So you have two interval, I mean the 2 points, 2 roots. Okay, if this bracket square of x minus 3 equals to 16. So for the left hand side you have 7. For the right hand side you have -1. So if you draw a graph like that, so here, let's say here is your 16. But I want to set the value of this range. Okay, and here is your -1 and here is your 7. Okay, that means this quadratic graph intersects with the y equals to 16 horizontal line when x is -1 and 7. And for this question, it wants you to find the set of values. So you must get this range. Alright? So your final answer should be -1 from there. Set the value of x from -1 to 7. So this is the answer. Okay. I think I have insufficient space already. Maybe I can create a new page. So let's proceed to the fourth part. You have the new function. Function g is defined by g maps to x to get 2x plus k. For x subsets to Orion numbers, find the value of constant k for which the equation g f(x) equals to 0 has two equal roots. Okay, so this is the question that involves composite function and the discriminant because it says that the two equal roots. Okay, ask yourself, what does the two equal roots mean? It means the discriminant b squared minus 4ac equals to 0. That means for this gfx quadratic function, okay, why can I confirm that gfx is a quadratic function? Because when you substitute this fx inside here, you're still getting a quadratic function, okay? Just that this quadratic function has been transformed, all right? So we can write like this: g f x equals to 0. Let's find the g f x first. So it is a g. I'm not going to use the fx. Okay. Oh, sorry about that. This third question, just now I've mentioned there's another alternative method, which is you can also expand this back to this quadratic and then set it into the general form equal on the left hand side and 0 at the right hand side. Yeah, it is also acceptable. You can do it in this way, but I'm not going to perform over here. And let's substitute with fx as the original equation, which is the general form of this quadratic function. And your gx is 2x plus k. Okay, just substitute inside here. Here is your x and plus k. Okay, and expand inside. Be careful, make sure not to make a careless mistake. I may make a bracket because since these two terms are all constants. Okay, so you may set gfx equals to 0. So that means 4x squared minus 24x plus 14 plus k equals to 0. Okay. Right. So let's carry out the discriminant b squared minus 4ac equals to 0. Just substitute all the coefficients, but identify a is 4, b is negative 24, and c is your 14 plus k. Okay, 1, 2, and 3. Substitute all inside the discriminant, then you will find a k from the question specified. All right. So your answer should leave it as 22. Okay, so that means your k is 22. Any question? Okay, if I have no question, I may proceed to another passive questions, which is this question. All right. You may give me some time. I need to make a preparation. So for this question, some of the part involves the inverse function. Okay. Alright, so let's begin this question. So this question is from 9709, October November series 2010, paper 12, question 7. And let's take a look at this question. The function f is defined by fx equals to x squared plus 4x minus 4x plus 7 for x is greater than 2. Express with fx in the form of this vertex form and hence state the range of f. Yeah, so this is beneficial for you to determine the range of the quadratic function from a vertex form. So I may provide to you the step lah. So I have fx equals to x squared minus 4x plus 7. And for this part, the marks allocated is very less. So I may directly give you the vertex form. If you want to do the further verification, and you may perform the CTS method by yourself. Okay, so I'm not going to discuss this further and state what is the range of the fx. Okay, so your range of the fx is greater than 3 because since the a is positive and it has this quadratic, this function has a minimum point. All right, so let's take a look at the second question. So for this part, it wants you to convert this fx into the inverse function. So for the inverse function, you let your fx equals to y first, and then change the subject with the x in terms of y. Alright, so I have y minus 3 square root plus or minus and also plus 2 as your x. Yeah, for this part, you must take note now. So, what is the condition of this square root? Yes, y minus 3 must be always positive. Okay, for this domain. So in this case, you need to separate into two cases, which is the 2 plus, square root y minus 3 plus 2 or negative y minus 3 plus 2. Okay? So what you must follow this condition of the domains. So this function is defined when your domain of x is greater than 2. Okay? So you can try to substitute y equals to 3 because the fx can the range of fx starts from 3, which is the domain of this inverse function. Okay, so try y equals to 3 first. What will you? Oh, I may try 4. Okay, 4 minus 3 is 1, so 2 plus 1 is 3. Okay, this one makes sense. And for this 4 minus 3, 1 is 1. So this proves that the negative side does not satisfy the domain. The range of this inverse function. Okay, so state the domain. That means your inverse function, you need to convert this y to the x. Okay, x minus 3 plus 2. And what is the domain of the fx? The f inverse. Actually, it is a range. It is a range of the fx. Okay, so is x greater or equal to 3. Alright, okay, let's proceed to the next part. Function g is defined by gx equals to x minus 2 for x is greater than 2. Function h is such that the function f equals to hg and the domain of the h is x is greater than 0. Obtain an expression for the h. Okay, so I think I don't have enough page to perform the steps, the solutions for the third part. Okay, given that your fx equals to hgx. Let's obtain the hx first. What is my fx? The fx is the vertex form. Okay, the bracket square x minus 2 plus 3. But what's my hgx? Okay, so first you substitute the gx first, which is your x minus 2. Okay, that means make sure that the range of the h must lie in the domain of g. Alright? Okay. So how to get rid away this one? So I need to get the h inverse x first. So I let y equals to 2. Alright, and I swap the subject is x, y plus 2. Okay? And to get the expression of hx, you just put this x as x plus 2. Okay? So I have x plus 2 minus 2 x squared plus 3. So my hx will be x squared plus 3. Alright? Why? Because of, in order to let it become hx, let me substitute the gx as inverse hx. Okay? So h times h inverse x equals to x. This one you should learn from your secondary school or O-level IGCSE. Okay? So the rest of the questions I need you to try out by yourself. And let's move on to the summary of the chapter 2 before I end this video. Alright, here is a summary of this chapter 2 functions before I end this video. Okay, so what is function? Function is a relation. How to know whether the function is valid? Because the function is one-to-one or many-to-one relationships. Okay, so what is the purpose of doing the vertical line test? The vertical line test is to test whether it is a function or not. Okay, next, this next subtopic, which is the basic graph. You need to know the basic 6 types of graph except for the cubic function. Okay, because the cubic function does not exist in your syllabus of the A level. Alright, and some of the certain domain and the range of their general form you need to get to familiarize, and how and what is the pattern of their graphs you need to know. Alright, and the third part is the transformation of graph. Let me jump to the summary. So for the vertical transformation, it has a translation of the 0a, where this a positive, this is positive. And for the reflection for this entire, you need to just put negative at beside of this entire function, which is the reflection in the x-axis. And for the vertical stretch or stretch parallel to the y-axis with the factor k, that means when this k, when the fx increase by k times, this times k, factor also k. Okay, and for the horizontal, got two transformations are opposite from the vertical transformation. So when this is negative, this is positive, and the reflection in the y-axis is just negate the x. Okay, negate the domain. And for the horizontal stretch or stretch parallel to the x-axis, this a times the x with the factor of the reciprocal of a, which is 1 over a. Alright, and also always remember that the order of the transformation is important, or the sequence, okay? And for the domain and the range, this f maps to x to get y can be expressed into this form, and you may convert this. And please read through the question carefully for the domain or the range from the question stated. Alright, and the piecewise function not likely to come out. However, you may see this in your further statistics. Stay tuned for my subsequent video. And for the composite function, you need to know the order of the composite function. Maps this first and then maps this first. And you need to know some certain composite functions, especially the composite function only exists when the range of the second function lies in the domain of the first function. Okay, first function means you function this first, you map this first, and then you map this. Okay, so for the inverse function, just convert back from your fx into y by using the inverse function. And this thing you need to know, that means for the domain of the inverse equals the range of the f. Domain of the f equals to the range of the inverse function. And always remember this statement. Okay, the inverse function is not equal to the reciprocal of the function. And inverse function only exists when fx is 1-to-1 relation, okay, by using the horizontal line test. Alright, so it comes to the end of the video. So in the next chapter, we are going to discuss the coordinate geometry. Although I haven't copied yet the coordinate geometry, but guys, please give me an ample time to complete the notes and extraction of the exercises, okay? Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.